Today we're going to talk about accessing databases in Java. This is a follow-on from the previous session where we looked at relational databases and SQL. So those concepts we're going to bring forward now into here to see how we can use those concepts from a Java program. As a recap, it's useful to use data between executions. So we keep the data from the previous execution of the program and then reload it or make it available again to the subsequent executions. This idea of persisting data is really very important for businesses. Just think about your bank account. You really would not want your bank account balance to be reset to zero every time the program was restarted. We also want to store data. We could use files. In today's example, we're going to use databases. And we could, if we wanted, store entire objects in various ways, one of which is to use JSON strings. So if we want to access relational databases from Java, then the first thing we need to know is it is easy to do. The second thing is that there's just a little bit of variation in connecting to a database. Each connection will depend upon the database management system that we're using. And after connection, the really lovely thing about using Java is that all the interaction is the same thereafter. All you have to learn from one database to the other is how to connect to it. The rest of it is standard Java. Now, the database that we use will determine what kind of connection architecture we will need. If we're using a database management system that does not have Java database connectivity classes, then we will need to use what is called the JDBC ODBC bridge. Every database manufacturer provides an ODBC driver. ODBC means Open Database Connectivity. Latterly, some of the database manufacturers have provided their own Java classes for connecting to databases. And we'll very briefly show an example of that in a few moments. But either way, whichever route you are taking, the concept is the same. Your Java class will use one route or the other to connect to a database and then to manipulate that database in some way, using the SQL commands that we looked at in the previous session. I suppose I should mention here the JDBC ODBC bridge is shipped as part of the Java SDK. The JDBC route will depend on the database manufacturer, and you will need to download their classes from their website. Usually it's for free. Now, to connect to a database, there's a little bit of preparation to do. First of all, you need to import the SQL package because it makes available some of the classes that we shall need. And then, depending on the route, you'll need a URL for your database. For the JDBC ODBC bridge, the approach will be a URL that consists of JDBC:/ODBC:, and then the driver name. Now, that driver name is the name that you will have given to the driver when you created the driver. What we're not showing here, because we don't need it for this session, is that you would have to go into your Windows configuration and create an ODBC driver for your database management system. We're going to be using databases that have got JDBC classes. So we're not going to use the bridge architecture. Instead, we're going to use the JavaDB that ships with Java. And that means that we need to know the URL of the database. The easiest way of finding that out is to create the database in NetBeans, go to the Services tab, and having created your database, you could right-click, go to Properties, and the database URL is just here. You can click on the three dots, and you could then copy that URL and paste it into your program. If you're using some other database, then you will need to know what the URL is for that database. We have at the university here an Oracle database that can be used by students. And the URL for that, for use from within a Java program, is this here. So JDBC:/Oracle:/thin@ and then the URL of the database, and then a colon, port number, colon, and then system ID. With those URLs, whichever one it is that you need for your system, you're then ready to connect to the database. Again, there's a bit of variation depending on the architecture that we're using. For the JDBC ODBC bridge, in a try-catch structure, you will need class.forName and then this string here. That's always going to be the same because it's accessing the standard classes that ship with the Java SDK. When you're making use of JDBC classes that you've downloaded from the database manufacturer, then you will need to consult that manufacturer's documentation to find out what class name you should be using. For JavaDB, we need the client driver class, and that will be the way, as shown on screen here, that we register a driver for that database. So depending on those two routes, we'll have loaded the correct class into the program ready for use, which means then that we can connect to the database. So you can see in the example code here that we have got the registration of the correct driver class, and then to connect to the database we use drivermanager.getConnection, passing in the URL for that database, then second parameter is the username for the database, third parameter is the password for the database. Now, once you've done that, there are no more differences in the Java code. So having connected to the database, whichever relational database you're using, you can just go on and use the code that we're going to demonstrate now. If we want to query the database, so use a select statement, we need to set up a statement object. Well, here's a variable in which we can hold a reference to that object. It's of type prepared statement. Later on, we're going to need a reference to the result set, which is the product of executing a select statement. Remember, a select statement is going to extract a certain number of columns and a certain number of rows from one or more table. And what it's going to do is to present all of that selected data as a table. And that table is called a result set. To execute the query, the first thing we do is to use that connection object that we set up and then call prepare statement and pass in the SQL string that we've set up here, select star from club. Please note that in this SQL command, unlike when you're typing it for yourself in an editing panel like we did in the previous session, we do not use a semicolon within the SQL string. That string is then used to prepare the statement that we want to execute, and then, having created that statement object, which is the result of calling prepare statement, we can then call from the statement object the execute query method. Now, we use execute query because our SQL string starts with the reserved word select, and therefore we know it's a query, so we call execute query. That's going to send our SQL string to the database. The database will execute it and will return the result set object that contains the data that has been extracted from the database by the select statement. To process that result set, we now access the first row by calling rs.next. Now, the method next will check, first of all, to see if there is another row that we have not yet processed from the result set. So if there is at least one more row, that row will be loaded and then we return true so that the while statement will continue to execute. And that means that we've got the next available row ready to be accessed. And you can see that we're accessing two columns, club ID and club name, and we're accessing it by using the result set object and calling from it a get method. For club ID, we know it's of type integer, so we're calling getInt, and it will extract that string from the result set, convert it into an integer, and pass it back. We're also accessing club name, which we know to be of type string, so we're calling rs.getString, and that will extract the string from that column in the current row that we're accessing in the result set. In this example, the processing that we're doing is simply to output it. The processing, once done, means that we can no longer go back and access those columns. So this is a use once kind of approach. rs.getInt can only be used on club ID once. Having accessed that column for this row, we cannot access it again. Next time around the loop, rs.next is called. It will check to see if there's another row available that we haven't processed yet. If there is, load it and return true, which means we'll go back in to the loop. And now when we call rs.getInt on club ID, because it's a new row, we can access that column again, but only once per row. So we'll go round that loop until such time as we've processed all the rows in the result set. When we've finished processing all the rows, rs.next will see that there are no more rows to process and therefore return false. And that will stop the while loop. Having processed all the rows in the result set, we then need to close the result set and then close the statement. It might be, if we finished using the database connection, that we should close the connection as well. In our program that we're going to use, we're going to do quite a few things in the one program, so we're going to leave the connection open. So just a couple of things to point out. In the getInt and getString methods, we pass a parameter that is the name of the column. As defined in the table, the method will return the correct data type if we call the correct method. We could indeed call getString for club ID, and it'll just return that data as a string. It might be that we just need to get it as a string rather than an integer. If we want to insert data, well, we know what the insert SQL command looks like, so we just put that into our SQL string. We don't have to split it like I've done here, but I tend to do that because I think it's more readable. So insert into club name, values. Notice the use of the single quotes for that string, and again the absence of the semicolon at the end of the SQL command. We still have the semicolon at the end of the Java statement because otherwise it wouldn't compile. Now that we've set up the SQL string, we can prepare a statement by calling the connection.prepare statement, passing in the SQL string. That gives us a statement object from which we then can call execute update. Now there's another thing to note here. We only use execute query for SQL commands that start with the reserved word select. Every other SQL command we use execute update. So for inserts, deletes, as well as updates, and drop table and create table and so on, all of that we'll just use execute update. And what this will do is send the SQL string to the database. The database will execute that string and return an integer that gives us the number of rows that were affected by that statement. Let's say we're deleting more than one row. In that case, the integer will be greater than 1. So if we've deleted 3 rows, the integer will be 3. In this case, we're inserting a single row. So we expect that row count will have the value 1. And if we wanted, we could test the value of row count to make sure that it is 1 to verify that a row was inserted. In our example here, all that we're doing is outputting the value of row count and then closing the statement. There's no result set with an update, so we don't need to close a result set. Here's an example of updating data. Again, we have a prepared statement with an SQL string, update club, set club name equal to Staffs Rovers, where club name equals Staffs United. So it's going to change every club, there'll only be one, with the name Staffs United and change its name to Staffs Rovers. And the syntax, or these commands that we're using here, is pretty well the same as what we saw in the previous slide. So we're going to call prepare statement, passing in that SQL string, then execute update and get the row count. In this case, we're just outputting it, but if we wanted, we could test it to see that it was greater than 0. Delete data, we use a delete statement, delete from club, where club name equals staffs rovers. So there's our string that we've set up. We can then pass that as a parameter to prepare statement, and then call execute update, which returns a row count to say how many rows have been deleted, and we're outputting it. So the syntax for those three statements, insert data, update data, and delete data, all the same. The only thing really that's changing is the content of the SQL string. It's all well and good to hard code everything so that we can always delete the same rows or always update the same values, but that's not very flexible. A much better idea is to use parameters in our prepared statements, and here's an example of it. What we're going to do is to use a question mark as a placeholder for a parameter. So what we're saying then in this SQL string is we're going to insert into club name, and the value is going to be one question mark. So that's a single placeholder. That will be a place where we can put a parameter value. And the way that we set that value is to call prepare statement first, so that the statement insert into club name values question mark is put into the system as a prepared statement. Then we need to give that question mark a value, and we'll do that by calling statement.set something. We know that the value we want to put in is a string, so we're going to call setString. If the value that we're going to put in is an integer, we would call setInt. So this is quite important to know what data type you're putting in, because if we're going to put in an int value, then the value we provide will be verified to make sure that it is an int. This is a safeguard against a hacking technique called SQL injection. You might have heard of it. I'm not proposing to talk about it in any detail today. The idea of using a prepared statement is a safeguard against any attempts to violate the integrity of your database. A few years ago, a well-known telecoms company lost quite a lot of data to a 15-year-old lad from Northern Ireland who used a little bit of SQL injection and managed to steal customer data. So we don't want to leave that little door open for people with nefarious intentions. So what we'll do instead is use prepared statements, which is what I've been showing you, and we will provide placeholders, these question marks, for parameter values, and then call setInt or setBoolean or setString or setDouble and so on, so that we can verify that the type of data we're actually going to attempt to put into the database is indeed of the correct type. So in this case, we know that the club name is going to be a string, so we'll use setString. We've only got one question mark, so we'll just set the string to be number 1, so placeholder number 1, and team name. Now the thing to watch out for here is that the placeholder indexes start at 1, which is foreign to everything else that we've seen so far in Java, where indexes start at 0, but not with the SQL prepared statements. This is the first placeholder, so we'll use index of 1, and we're passing team name, which is a value that could be supplied by the user in some way or another. Having set that placeholder, the statement is now populated with some data, and we can use the prepared statement, so we'll call execute update as usual. That will now insert into the club table a club name that is equal to whatever the user has supplied in team name. What we're going to do now is to take a look at this example. In the main method, we're going to be inputting something from the keyboard, so we've got a scanner set up for that. We're going to use the sample JavaDB database, into which I have previously added the 2 tables that we were looking at in the previous session. Having set up that URL, here's a variable that currently is set to null. It's going to be a reference to a connection object, and to set up that object, we register the client driver. Now, that is not a class that ships with the standard developer kit. This is the class that goes with the database that we've chosen to use. It's one of the JDBC classes. So we need to make that available to our application. The way that we do that is in the libraries for the project, we would right-click, add jar, and then go to the installation of the Java DB. And in there is a folder called lib, inside of which there is a jar file, and we would add that jar file. It's called derbyclient.jar, and that's the one that we add to our project. That will then make this jar file available in the class path for our project, and then we can start using those classes as if we had written them ourselves. I'm not bothering with an import statement up here for client driver because I'm using the fully qualified path name for that class. Now that I've set up the client driver, I've registered it, I can now call drivermanager.getConnection, pass in the URL and the username and password for that particular database. That connection is now ready for use. We can use it in this method where we query the club. I've taken that code and put it into a method because I'm using it in several places, as you can see. Let's take a look at that all the way down in the code here. Query club. We're passing in the connection so we can make use of that. Here's the SQL string, select star from club. We're using the connection that we've passed as a parameter to prepare the statement, and then we're going to execute the query. And just as we saw in the lecture slide, we're then iterating through every row of that result set, and for each row we're simply going to output the value of club ID and club name. Close the result set, close the statement, but I'm not closing the connection because I want to use it again in other methods within this application. Having queried the club so we can see what the current state of play is, I'm then outputting this message here to say I'm inserting a row, and then I call insert club. So I hold down control and click on there, and it jumps me straight into this method. Hard-coded, insert into club name values, staffs united, and go through the process of inserting it into the database. Come back to where we called that and then call query club again to see the effect of the change. Then we update in the way that we saw a few moments ago in the slides, then query to see the effect, and then delete to remove the row that we've just put in there, and again call query. So those are all hard-coded values. What I want to do now is to ask the user to provide a new club name and then read that string, so that becomes my club name that I'm going to pass to a different version of insert club. This is one where I'm passing the connection and the club name. So what it will do is use an SQL string that has this placeholder. We prepare the statement for that SQL string and then set the placeholder, number 1, to club name, and then execute update. And having done that, we query the club again just to display the latest set of changes in that table. Now we want to update the club name. So we're going to prompt the user for a new club name. So that gives us club name 2. And we're going to call update club, passing in 3 parameters: the connection, the original club name that we read earlier on from the keyboard, and club name 2. When we come into the update club, we are now setting up this SQL statement. Update club, set the club name equal to first placeholder, where club name equals second placeholder. So we've got 2 placeholders, both of which need to be set. The first thing we must do, of course, is to prepare the statement with that SQL string, and then we can set those 2 placeholders. So we'll use for placeholder 1, new club name. We know it's placeholder number 1 because it's the first question mark reading left to right in that statement. The second placeholder will be the old club name, then we can execute update. Having done that, we can query the club, then delete that club with the new club name and query the club again. If we execute this program, we can see that the current contents are the 3 clubs that we inserted when we populated the database initially. Then we're inserting a row. There it is, Staffs United, with an ID of 4, so that's an auto-generated primary key value. Then we're updating the row, change Staffs United to Staffs Rovers. Then we're deleting that row, so we're back to the original 3 clubs. Now we're being asked for the new club name. Let's call this Graham's Team. We can see that it has been inserted. Notice the primary key value is 5. Even though we've deleted the one that has got a primary key of 4, that doesn't change anything. 4 has been used once. It won't be used again when we're auto-generating. Now Graham's Team is inserted. We ought to change this to something like Jan's Club, and we can see that Graham's Team, number 5, was updated to Jan's Club, so the name has been changed, and then we're deleting it again. So we can parameterize these statements to allow for variable input to be inserted. We don't have to hard code everything. So what we've seen now is 2 types of database connection, the JDBC ODBC bridge or the JDBC classes. Those classes we would have to download from the database manufacturer for that database that we're using. The way we connect to the database will depend on the database that we're using, and after that everything is standard. It's all the same. So we can then query a database, insert rows, update rows, delete rows. We could even create tables if we wanted to, or drop tables, and so on. So as I said right at the beginning, it's actually really straightforward to connect to databases from a Java program. What you've seen here will work for any Java program. It might be a program where you've got a graphical user interface. It might be, as we've seen here, a command line application. It might be a web application where you've got, let's say, some Java server faces and you've got a manage bean that sits behind those facelets. And from that Java bean, if you wanted, you could connect to a database. So wherever you're using Java, if you want to connect to a database, what we've looked at in this session will work just fine.